You've probably heard of dark matter and dark energy, but do you truly understand what they are and why they remain one of the greatest mysteries of the universe? Today, we'll explore the fascinating story of groundbreaking scientific achievements, mysterious discoveries, and unanswered questions. Let's begin this journey. Over a century ago, scientists began to notice a strange phenomenon in the universe. Galaxies were moving much faster than what could be explained by the gravity of the visible matter. What was causing them to move so quickly? How could we observe these objects but not see them? This is when dark matter was proposed as a hypothesis to explain this. Dark matter doesn't emit light, doesn't reflect light, and cannot be directly observed with our current tools. Yet, measurements have shown that dark matter makes up about 85% of the matter in the universe. But what it is remains an open question. You might think that something so prevalent in the universe, but impossible to see or measure, is just a complex scientific concept that few people understand. But in reality, it plays a crucial role in shaping the structure of the universe we live in. The clearest evidence of this comes from observing the movement of galaxies. Scientists found that galaxies were moving much faster than predictions based on Newton's laws. It seems that an invisible, powerful force is acting on them, but we haven't yet discovered its nature. While dark matter is a physical mystery, dark energy emerged as one of the most remarkable discoveries of the 20th century. In the 1990s, astronomers discovered that the universe is not only expanding, but is doing so at an increasingly faster rate. This was completely contrary to the assumption at the time that the universe's expansion would slow down due to gravity. Dark energy was proposed as an unseen force that accelerates the universe's expansion. This theory shook the scientific community because, before this, we had only imagined the universe expanding at a slower pace. But the discovery of dark energy overturned all of that. It is an invisible force, incredibly powerful, causing the universe to not only exist, but also continue expanding at an accelerating rate. The strange part is that, even though scientists have discovered the existence of dark energy, they still don't understand its true nature. We know it accounts for about 68% of the universe, but we can't figure out what it actually is. Just like dark matter, dark energy can't be observed directly, but can only be inferred by its effects on the universe. So, why are dark matter and dark energy so important in science? Simply because they help us understand the universe we live in. One of the most prominent theories suggests that dark matter consists of particles that don't interact with light and only interact through gravity. A key example is Fritz Zwicky's research in the 1930s, when he observed galaxy clusters and noticed that they seemed to contain much more mass than could be seen with the naked eye. Through research, dark matter appears to be a form of invisible matter that doesn't emit light or radiation that we can detect with our current equipment. One widely accepted hypothesis is that dark matter could consist of extremely small particles that do not reflect or emit radiation, but interact through gravitational forces. As for dark energy, scientists have also proposed fascinating theories. One of them is that dark energy is a form of energy that cannot be seen, but has a profound influence, accelerating the universe's expansion. Dark energy might be a form of energy that fills all of space and has an impact on every component of the universe. This might explain why the universe continues to expand at an increasing speed, contrary to previous assumptions that its expansion would slow down. These theories are not something we can easily explain, But if we look back in time, we can see that many things that seemed unexplainable in the past are now understood thanks to science. Take Isaac Newton's theory of gravity, for example. When Newton invented the law of gravitation, he couldn't explain why gravity had such a strong effect on visible objects. However, thanks to later advancements, particularly Einstein's theory of relativity, we now have a much clearer understanding of this force and its impact on the universe. Another example is the discovery of electromagnetic waves by James Clerk Maxwell in the 19th century. Back then, scientists could not imagine that this invisible wave could carry information. But today, we use electromagnetic waves in various modern technologies such as phones, radios, and televisions. The discovery of electromagnetic waves marked the beginning of a new era in science and technology, and it serves as proof that science can unravel mysteries that were once unimaginable. So, what's the question here? Where will dark matter and dark energy lead us in the future? Although we still don't have all the answers to these mysteries, advancements in technology and research are gradually revealing some answers. Advanced telescopes like the James Webb Space Telescope could help us observe and study these phenomena from perspectives that weren't possible before. Along with progress in theoretical physics and experiments, we are getting closer than ever to uncovering these mysteries. Scientists are still trying to study dark matter and dark energy in more detail, not only through astronomical observations, but also through experiments in physics labs. Dark matter and dark energy are going to remain subjects of ongoing debate and research. However, their very mystery keeps us searching and discovering. Perhaps the question is not whether we will solve all the mysteries of the universe, but how we will continue to search for answers in our journey through scientific exploration. Dark matter and dark energy are not just scientific concepts, but profound questions about the existence of the universe and our place within it. Surely, in the years to come, as science continues to progress, these mysteries will slowly be unraveled. What do you think about the possibility that we'll find dark matter and dark energy in the near future? Will technological advancements help us see these invisible forces? Could they change the way we understand the world around us? Share your thoughts in the comments, as there's still so much for us to explore.